Hi guys, so I'm going to solve this exercise for a quick hint on this one. So okay, let us pick up for this one. These are exercise that came from 2019. I guess this 2019. I'm not sure if it is summer or winter, but it's from 2019. GTU for math 1. Okay, for math 1. So let us solve this one. Okay, for the first exercise, okay, here the first exercise, un is equal to n, okay, upon log of n root n. Okay, so here we can solve by root test. Okay, why root test? I have here n, okay, an exponent, and I have here n. So limit of this n into root of 1 upon n into 1 upon n. Okay, it's like when I have here, just try to imagine, okay, if I put here 1 upon n, this limit will be 1, and this one will be n. This will be only log of n, so it's easy. So by root test, you get limit of the un to the power 1 upon n goes to infinite. This will be what? Limit of n upon log n, okay, raised to n, 1 upon n. So this is easy. This will be limit above n upon 1 upon n, okay, and limit down. You can write limit down, it's okay, or you can just write only one limit, this one, and here you have log of n, the power n times 1 upon n. This and this will be cancelled out, so you will end in limit of 1 upon n. We know this limit, and this is log of n. This will be what? This limit, we know by notation it is 1, and this is log of n. N goes to infinite. This will be 1 upon infinite. This will be 0. 0 is less than 1. So by root test, it is conversion. Okay, just like this. Done. Let's go for the second exercise. The second, it is what? The second exercise, it is this one. It looks like complex, okay, n plus 1 factorial upon n plus 1. See, this exercise here, whenever you see polynomial, factorial, you see polynomial, power, polynomial, factorial, okay, everything like this one. This is nothing more or less than, yeah, this is a kind of, this is showing you that this is only the easy way to solve this one. The easier way is to apply ratio test. Okay, ratio test. So now limit of un plus 1 upon un, this will be equal to, what is un plus 1? Limit 4n plus 1 times n plus 2. Where you find n, put n plus 1, just like this, upon n plus 1, n plus 2. Okay, 1 plus 1, 2. Then this is dividing by un. What is un? The same expression, n plus 1 factorial upon n plus 1. So what we have to do here, just substitute 4. Okay, sorry. This will be limit n goes to infinite This will be 4 to the power n, okay, 4 raised to n times 4. Then here times 4. Then here I have just to make it be equal to this, okay, just this will be n plus 2 n plus 1 factorial, because I want to cancel them, okay. Then here also I can just make n plus 1, okay, raised to n plus 1. The other one is n plus 1 time this will be inverse n upon n plus 1, all divided by 4 to the power n, and here n plus 1 factorial. The next step is just to simplify this one and this one and this one, okay. So we cannot simplify this and this, that's impossible. So we will put together all the power together and all the polynomial together there. Limit goes to infinite, powers come together, this and this. This will be n upon n plus 1, all to the power n plus 1. It's okay? Nice. Now here will be 4 n plus 2 upon n plus 1. Okay, so this limit that you have here, this limit, okay, there is a theorem that says whenever I have limit of un time an, okay, this one and goes to infinite, this is the same as I write limit of u n time limit of a n, okay. I can separate the limit just like this one, limit for this time limit for this will be the same, okay. Okay, just like this. So this is what I'm going to do. This one, this will be limit of n upon n plus 1, n plus 1 here, time limit for n upon n goes to infinite, only for n upon n. Just pick up the greater n with the greater power here and n with the greater power here, okay, with this coefficient, okay, then just divide them, okay. Here we know that n and m will be only 4, so this will be 4 sorry, will be 4 times this limit here, okay, this limit here. Now see, here this is a limit that can be calculated with Euler. This is Euler, okay. I don't know if you remember, whenever we have limit of 1 plus 1 upon x to the power x, when x goes to 0, this is equal to Euler, okay, not 0, when x goes to infinite, this is 0, this is equal to Euler. So to be Euler, here this is Euler to the power 1, here we have to have this guy inverted in the exponent, okay. We are going to make this one similar to this. So this will be 4 limit when n goes to infinite. So here we do not have 1, okay. What do we have to do? Just add, usually I add 1 plus n, okay, n plus 1, and take 1 minus 1, okay, to the power n plus 1. So now here we will get this one, n goes to infinite, we will get 1 plus, just find the common denominator for these guys, it will be what? It will be minus 1 upon n plus 1. And this is n plus 1. If you see it well, if you check it well, okay, just check it. This is 1 plus minus 1, and here n plus 1 is down, and here it is up. So directly you can just write down, you can know this one is Euler, okay. But Euler, check here, what is the exponent for Euler? 1 because here I have 1. So here just compare. What's the exponent for Euler? Minus 1. This will be 4 times Euler to the power minus 1. This will be 4 by Euler. 4 by Euler, this will be a number greater than 1. So this is greater than 1. Okay? If this is greater than 1, so by ratio test, it is divergent. Okay, because 4 by Euler, it is 2 point something. This is greater than it's greater than 1. So we can say that this one, okay, this limit diverge, okay, by by ratio test. Let's move for another one. Okay, then we have this this series, n goes to 1 and 3, x minus 2 by n. Here they ask, okay, to find what is x, okay, for the series to be absolute, okay, absolute convergent. They just ask us for absolute convergency of of this expression of this guy. What is x? So just remember, here we apply absolute what? Absolute convergency for root test. Okay, it says what? It says that if I had a series that is convergent by using root test, so it is in this interval, this series is absolutely convergent. So just put this one, so I will get this one. I will find by root test this one. Okay, so forget, so here un will be 3x minus 2 upon n, and this one. Apply now root test. un to the power 1 upon n. Okay, when n goes to infinite, this will be what? This will be limit of 3x minus 2 upon n, 1 upon n. Then just apply this guy, 1 upon n. What will it be? It will be, well, limit of this guy, just sorry, no need for this one. This is already there. This is n, that is already here, okay, time 1 upon n, sorry. Okay, this n is this, and this n is from the formula. Okay, now what do we have to do? This guy will cancel out with this one, so n here will be infinite. So I will get here 3x minus 2 upon, okay, this is cancelled out with this one, upon n. Okay, so what do we have to do? Just substitute for this guy. We get 3x minus 2 upon infinite. What will it be? It will be 0. Okay, what does it mean? It means that here, okay, here, whatever n, okay, x belongs to any real, okay, it means that here the convergency of this series do not depend on x. X can be any value, okay. The interval of convergency is x belong to real, and x can be any value, okay. X can be 1, 2, 3, 4, 5, 6, 7. X can be any number, okay. So we can say that this series, okay, is absolutely absolutely conversion. Okay, any number you can put here, it will converge. Okay, for x, x can be whatever numbers. So the interval of convergency will be equal to what? The interval of convergence will be from minus infinite to plus infinite. Okay, just like this, just like this. So thank you, hope you can enjoy this, and see you next time.